Okay, so today we're going on section 8.1, which is quadratic functions. And we know that we've seen quadratic functions before, but we haven't done much with them. In order for it to be a quadratic function, it has to have an exponent of 2. It cannot have any other exponent but an exponent of 2.
Why?
Because that's what makes it quadratic. Because quadratic means exponent of 2. We went over that before.
You sure?
Yes, I'm sure. Okay, so if we're looking at example 1a, we want to determine if this is a quadratic function. Okay, you don't really have to worry about your x's, but we do have to worry about our y's. Okay, so we're going to find our common differences. There's only 3 ways to tell if a function is quadratic. You can tell by the table of values, you can tell by a graph, or you can tell by the equation. Okay, so 0 to 1 is 1, 3, 5, 7. Okay, these are your first differences, and this is what tells you if a function is linear. We don't care about the function being linear because we want to know if it's quadratic. So we have to do this again, and we have to find our second differences. Okay, our second difference is all the same.
Mm-hmm. Yeah.
Then it's quadratic.
But yeah, I don't get it. I don't. On this one, we have to say yes or no.
Mm-hmm. Wow. Or quite a few of them. Yeah, it's just yes or no.
I didn't get that at all.
Okay, so let's do another table. I'll make one up. Okay, so what do I do to get from 1 to 5?
Add 4. Oh, okay, now I
From 5 to 9?
add 4.
And from 9 to 11?
2.
Okay, and we don't care about these because these are our linear differences. We care about our quadratics. So what do I do? No.
You add, wait, 0? And then minus 2.
Okay, so are those the same?
Oh.
Hello. Does that make sense, Tana?
Okay, yeah.
Okay. Second way that I said that we could tell if a function was quadratic was by looking at the equation. And what does it have to be quadratic? Exponent of
2.
2. Okay, does this have an exponent of 2? Very good.
So it doesn't have exponent. It's just
Doesn't have an exponent of 2. Has to be 2.
it doesn't have exponent. I feel like
Yes.
eating.
Okay, so what about then, let's see. Does it have an exponent of 2? Yes.
Oh, wow.
Well, this part so far, right?
Always there's this part. There's always this part. That's done.
No, it doesn't. Okay, then the third way I said we could tell if a function was quadratic was by its graph.
Yeah,
Because a graph has, so we can tell by the exponent. Let's actually graph it and see. Now the values for your table that you guys are always going to use is -1, 0, and 1. Okay, that's very important that you use those values. Okay, so if I plug in -1, 2 times -1 squared. What's -1 squared? -1 times -1.
1.
It's 1, okay, and 1 times 2 is 2. So if I do 2 times 0 squared, 0 squared is 0 times 2 is 0. And then if I plug in 1, 2 times 1 squared, 1 squared is 1. 1 times 2 is 2. So if I plug those into my graph then, -1, 2, 0, 0, 1, 2.
Triangle.
It is a triangle. I am not a devil worshipper. You connect your dots.
You're so pink.
It does kind of. Okay. So you connect your dots and it should make this shape a U shape, or if it's upside down, it makes a shape like this. If it's shaped like either of these, then it's a quadratic.
Well, the top one is a B.
Well, okay.
No, the top one's 4.
So if it's like that, it's a quadratic. And it can be like a really flat graph, or it can be like really, really skinny. It just says
It's not as long as both sides are pointing up.
yes. Or down. Both sides down. They have to be pointing in the same direction. Okay, so let's do negative 2x squared then. Yes. Okay, so negative 1 squared is negative 1 squared is 1. 1 times negative 2 is, okay, 0, negative 2. So negative 1, negative 2 is 0, 0, 1, negative 2. So it just makes the graph upside down, right? Same looking graph, just flipped upside down. Make sense? Okay, taking those. Well, the exponent tells you how many times to multiply what's in the parentheses. So like negative 1 squared means negative 1 times negative 1.
Okay.
Okay, so then if I look at 3a, we need to decide how we can tell when our graphs are facing up and how we can tell when our graphs are facing down. Right? Because our first graph was facing up, our second graph was facing down. How do we think we tell that?
Negative. Positive. If it's negative, it's down. If it's positive, it's up.
Okay, and what if what's negative? The number out front, the leading coefficient. Oh, vocab! I'm so proud of you. All of you are using the vocab. Okay, so if our leading coefficient is positive, what direction is it going? Up. Very good. And if our leading coefficient is negative, it goes down. Okay, so on 3b, up, up, up. Yay! And on 3a, down. Alright, we're going to do 2 other things and then you guys are going to get started. They are not hard things to do, they are just more. No. Okay, it's going to ask you at times to identify your vertex of your graph. Your vertex of your graph is the point at the bottom or at the top. Okay? So in this case, it's at the top. What is that point?
I can't see.
1, 5. Okay? Okay, so 1, 5. And then we need to know if that's a minimum or a maximum. Now, I gave you guys hints over here. So if it's opening down, it's a maximum. It's max because it's the very top. So everything has to be under. If it's opening down.
Oh my god. Okay, so that's.
So this one is a minimum. Okay, I agree with that. What is that point? -2, -5. So that's got point and it's a minimum. Okay. Who's doing math? Who's doing math? Yeah. I know. Okay, then the last thing we're going to do is we're going to do domain and range. Okay, we've done domain and range before. But just as review, domain is your x values. And in the case of parabolas, your x values are always all real numbers. So use your all real number symbol. That means anything. Any number will work for x.
Okay.
Anything, the whole number will work for x. Okay, that's what that means.
Jillion.
Like that, billion, jillion. What? Any number in the universe will work for x. That's what that means, yes. Okay, now if we look at our y values, our range, we know that we're dealing with y values. And we care about our y value only at our vertex. So what is my y value at my vertex?
-1, 0, 1, 7. Negative, or negative, -1, +4.
Okay, and so which one of those values is my y value? 4. Okay, now, is this opening up or down?
Yeah, maximum.
Down, so it's a maximum, so what symbol do I use for maximum? Yeah, less than or equal to. Yay!
So that's all we have to put for that?
So I have to put that. Let's do one more, and then we'll be done. What do I use for my domain?
All something universal.
All real numbers. Okay, so our all real number symbol. Okay, it's -4.
And then
Greater than or equal to. Very good. Okay, so you guys are going to work through page 526 today. Your goal is to get through 1 through 21. Then we'll finish 22 through 38 tomorrow. If you get further, then just keep going.